Hi, great to meet you, everybody. Great to be here. I work in the Oak Ridge Leadership Computing Facility, and I'm going to talk about porting Fortran codes over to Kokkos. I'm the main developer of a library called Yet Another Kernel Launcher. It began somewhere in 2019 as a way to get to play on AMD GPUs. This was quite early for AMD. Kokkos didn't quite have a hit backend this early on. So I made the mistake of creating a portability library. There are a lot out there already. We have Kokkos, Raja, and the many names that Intel, CodePlay, Kronos, whoever applies to YAKL. And I was like, okay, this is yet another kernel launcher. That's what it became. YAKL kind of rolls off the tongue. Features began to accrue. And again, I came from the Fortran world, and it shows in my coding. And Fortran array behavior, transparent pool allocator, because people like to use automatic arrays in Fortran. I began to gain users, and feature requests started coming in. Much to my dismay, there were requests for hierarchical parallelism and streams, which was quite difficult to handle with a non-blocking pool allocator. We can talk more about that later if you want. A YAKL backend was pretty messy to add in there. Ended up having to use a union with Daniel Arnaud's advice, which I hadn't used since I was in high school. And so at this point, YAKL was basically becoming essentially a diet Kokkos. It was some of that refreshing portability with the fewer calories, so to speak. But it was losing its niche and gaining complexity. It was very hard to maintain. Again, I was practically the only developer with some help from Intel folks for YAKL. I lost access to testing on Intel and GPUs in an easy manner. And at this point, it was very clear that YAKL needed to go as much as possible. And it was replicating a lot of the functionality that Kokkos already does well. And it's simplified compared to Kokkos' functionality. So sometime, I'm bad with time, so sometime over the past year, I did switch it over to use just a single Kokkos backend, and very casually moved everything else to a deprecated folder and namespace. And I didn't even have to change the name. It went from Yet Another Kernel Launcher to YAKL as a Kokkos layer. I got to use a recursive acronym there. So Fortran development culture certainly has a lot of vices, but it has a few virtues as well in there. And one of those, in my opinion, is automatic arrays. If you want an array, just create it. Compilers tend to put it on the stack, which is fun when you try to run it through Valgrind. But frequent device allocation is generally too expensive. CUDA is working on this with asynchronous allocation, but still, if you have a pool allocator, you get better results. So this will be, one of the things that's nice to have, or at least to be able to link up to Kokkos. And in fact, you don't even have to do a great job optimizing this thing. You don't have to use a buddy allocator or anything fancy like that. Just a simple, naive, linearly search through for the first place you can fit your allocation request actually works quite well because it tends to overlap with kernel execution. And memory pools tend to improve CPU performance as well. This is going off memory, but I remember the TLB misses being quite a bit lower when you use a pool allocator on the CPU. And again, Fortran porting is still really common in my world. We have a lot of codes and Earth system models that still use Fortran. Porting them over is not for the faint of heart. And anything that can make that easier, thank you, Ubuntu, will be helpful. Simpler can sometimes be faster. The YAKL Parallel 4 is far less functional than the Kokkos Parallel 4 in the balance class. Part of the benefit of that is sometimes you can get away with reduced register usage. So with no further ado, if I were to make requests of Kokkos, and maybe Kokkos supports some of the stuff already, feel free to let me know if it does. But to be able to have a custom allocator for views to support underlying memory pools would be nice. I don't mind creating the memory pool myself. It's 30 to 40 lines of code. It's not that complicated. Having views that can have custom lower bounds and custom default lower bounds, I know that's not going to be necessarily easy to implement, but there's the request. If that's hard to do, at least supporting views that can wrap existing allocations and have a label for debugging would be nice. I'm certain Kokkos had a reason for not allowing labels for that, but there's the request. There is quite a challenge of using a non-blocking pull allocator with streams, as I mentioned earlier. These things can run in parallel, and you can end up aliasing memory allocations between two concurrently running kernels, and so you actually have to manage the deallocation for when you create an event in a stream and wait to actually, alias that pointer later. So having a custom callback for view deallocations would be nice. And potential support for these simpler parallel for and bounds cases to lower register usage would be nice. Thank you. I've noticed that, I think this is for AMD, I'm going off memory here. There was an if statement to make sure that you're not looping over more threads than you actually have available when you're doing hierarchical parallelism, and that if statement reduced the performance by quite a bit, like 30% or something like that. It was very odd. The AMD person with our Center of Excellence didn't quite understand what was going on there. I'm not sure I'm advocating for it. It's pretty risky, but there are things that could potentially improve performance if you don't need all of the bells and whistles that come with MD range. Finally, I'll give a shameless plug for using Frontier. If you've got a big idea with your Kokkos code that you've ported over, but you don't have enough compute power to handle it, I'm here to help. I'm your friendly neighborhood liaison. I'm happy to help get your code ready. On Frontier, we have 3 allocation programs. You don't need to be a US citizen. Doesn't have to be DOE mission-oriented, Department of Energy, mission-oriented science. It just needs to be an impactful science idea that we can scale up to use the majority of the machine. So please reach out to me. I'm happy to get you connected, and we'll see if we can find a way to get your science problem achieved. So thank you very much.
Thank you, Matthew. We have time for a few questions.
When you said the bounds on the view, you meant indexing from 1 or something like that?
Yeah, if you don't have strides and you have default lower bounds, you can get rid of some of these bookkeeping parts of the range class or whatever it may be. Okay,
yeah, talk to me after. And yesterday we discussed stuff like that. And the other thing is that the performance bug that you saw, just report it. Like, this is things that's...
It was reported on the Kokkos Slack channel.
So the Kokkos Slack channel is where you can check whether this is...
It needs to be a GitHub
whether
issue.
Yeah, you can if you're unsure, but there is very high chance that we will not act on it and forget if you don't actually open something.
Absolutely. Yeah, I'll get in touch with the user who mentioned it on Slack, and we'll get it into a GitHub issue. Thank you.
I mean, sometimes someone of us just does exactly this. It takes a Slack conversation, puts it into an issue. So.
Oh, great. Right.
Okay, so let's switch our next speaker.
Thanks, Matthew, again.